Hi, good afternoon, students, or whenever you guys are watching this. The moment you guys have all been waiting for, the final study guide review video. All right, so let's go through each of these problems. It's going to be about 43 problems, but that's okay. We'll do them one by one. We'll get through it together. I think 43. Let me try to look at this. 44, actually. My bad. One more extra. Anyways, let's get to it. -3 raised to the fourth power. Remember, 1 second, let me grab a calculator. Here we go. Remember, when you raise something to the fourth power, that's literally multiplying it by itself 4 times. But anyways, if you guys forgot how to enter that into your calculator, you would have to put that -3 in parentheses, and then you press this button, up arrow, to the fourth power, and you simply get your answer of 81. All right, 5 to the -2nd power. If you guys remember from the final study guide, or sorry, the finals notes, this negative, we have to make it a positive. We don't want negative exponents. We bring it down to the denominator. So we have 5 squared. Final answer, as you guys know, 5 squared is 25. So 1 over 25. All right, simplify -3 raised to the 0 power. Remember, any number raised to the 0 power, that's just going to be 1. Nice and simple. All right, question number 4. We want to simplify that. So remember, we go ahead and work one at a time. So let's just make our fraction. 3 over 27. Remember, if we just had that on a test, we go ahead and think of the greatest common factor. 3 goes into 3 once. 3 goes into 27 9 times. Right, so it'd be 1 over 9, but remember, technically, we don't need to write that 1. Let's just write it for now, though, just so you guys can see what I'm talking about. And then let's see, x to the 0 power. As we just said with number 3, anything raised to the 0 power is equal to 1. And then we want to go ahead and simplify these negative exponents. As I just told you guys with this problem, number 2, when we have a negative exponent and we need to move it to the denominator or the numerator, depending on where it's at, we switch it around and then it becomes a positive exponent. So since this y to the -9th is in our numerator, we move it down to our denominator, y to the 9th, make it a positive 9, and then we move the z up. That becomes z to the positive 9. All right, so that's what I was talking about with, we technically don't need this one, because if we multiply 1 times z to the 9th, that's still z to the 9th. So our final answer, z to the 9th divided by 9y to the 9th. All right, with number 5, very similar to this. I think you guys are used to solving it this way, where you guys go ahead and distribute this 3, so to say. Don't think of it as a distributive property. It's not the same thing. But anyways, this 3 applies to that 4. The 3 applies to that x to the 6th power. So let me just go ahead and rewrite this out. That'll be 4 cubed multiplied by x to the 6th power raised to the 3rd power. Everything gets raised to the 3rd power, right? If it's outside. X squared to the 3rd power, and then y to the 9th raised to the 3rd power. All right, simplifying that a little bit more, 4 to the 3rd power, that gives us 64. X to the 6th power raised to the 3rd power. Remember, we multiply those exponents. That gives us x to the 18th. All divided by x to the 6th and y to the 27th. All right, remember, same base. This is division, so we subtract those exponents. Final answer, we get 64. Subtracting 18 minus 6, we get x to the 12th. That stays in our numerator, and in our denominator, we have y to the 27th. All right, question number 6, simplify. All right, so we have that squared on the outside, just as we did with question number 5. We have to sort of think of it, distributing it to each of those terms. All right, so negative 5 squared gives us 25. X to the 7th squared, we multiply those exponents, that gives us x to the 14th. And then y squared. So y squared, we literally rewrite that. That is our final answer. All right, question number 7. We want to go ahead and simplify this. Remember, with these types of problems, it doesn't matter how we multiply this. But first, we have to go ahead and distribute that 3. Right, 2 to the 3rd power gives us 8. X to the 4th power raised to the 3rd power gives us x to the 12th. And then y to the 3rd power raised to the 3rd power gives us y to the 9th. And then let me just rewrite this. We have multiplied by 10x squared y. All right, and then as I just said before, it doesn't matter which order we multiply it. So let's just go ahead and multiply our numbers first. Final answer, we get 80. Multiplying our x's together. Remember, we add those exponents, we get x to the 14th. And then multiplying these together, we get y to the 10th power. All right, first page done. One step closer. All right, question number 8. We want to go ahead and simplify this very seemingly complicated multiplication problem. All right, so as we just did, let's just go ahead and multiply. Negative 2 times 3 gives us negative 6. Let's see all our x's. We have x squared, x, and x to the 5th. Adding those exponents together, we get x to the 8th power, right? 2 plus 1 plus 5. What about our y's? We have y right there, y right there. We say that's going to be y to the 5th power, right? 1 plus 4 gives us 5. And then lastly, our w's. We have w to the 3rd power multiplied by w to the 3rd power. That gives us w to the 6th power. Final answer. All right, question number 9. We go ahead and simplify that fraction. If we just had a fraction 45 divided by 25, we would think of the greatest common factor of those two numbers. That's 5. 5 goes into 45 9 times. 5 goes into 25 5 times. All right, dividing these two, we get x to the 5th power divided by x to the 3rd power. We subtract exponents, we get x to the 2nd. And then lastly, w to the 8th divided by w to the 11th. We go ahead and subtract those exponents. We get w to the negative 3rd. All right, so if you wrote this on a test, I'd give you half credit. Why? Because we need to simplify our negative exponents. As you guys know, we just simply bring it down to the bottom and make it a positive. So our final answer, let's see, we still have 9 over 5. We still have that x squared. But now we move this to the bottom and make that 3 a positive. That is our final answer. All right, question number 10. We have negative 4 multiplied by x to the negative 3. So remember, when something has a negative exponent, we bring it down. We don't care that this is negative. We only care about negative exponents. So that negative 4 still stays in our numerator. That changes to x to the 3rd power. That's our final answer. Oh, sorry, excuse me. I am exhausted after today. I am still at school making this video. But anyways, the value of a car is $27,000 and depreciating at a rate of 13% per year. So we use exponential decay function. Let's just go ahead and rewrite that out. A, 1 minus r, all of that raised to the t power. Our a is our starting value, so we have 27,000. Multiplied by 1 minus r. So if you just wrote 13 here, you'd be doing it wrong. Remember, we have to write it as a decimal. All of that raised to the 5th power. All right, so what's nice about these problems, we could literally enter it into our calculator. So let's go ahead and do that. Let me try to adjust this camera so it's not in glare. Okay, I guess you can't really see that. Let's just go ahead and do it like this. 27,000. Oops. 27,000 multiplied by 1 minus 0.13. All of that raised to the 5th power. We get 13,457. and 36 cents. So let's go ahead and write that as our final answer. 13,457 and 36 cents. And let's not forget our dollar sign. All right, question number 12. We're going to use the exponential growth function. So same thing, right? Except we have addition. A, 1 plus r, all of that raised to the t power. Our A is 899,000. 1 plus our rate is 0.01, right? As a decimal. All of that raised to the 12th power. Oh, excuse me. Wow, yawning a lot right now. Okay, so all of that, let's go ahead and put that into our calculator. 899,000, oops, not decimals, 1,000, multiplied by 1 plus 0.01. All of that raised to the 12th power. We get $1,013,015.70. Let's write that. $1,013,015.70. That is our final answer. All right, so those are fairly easy. I remember on the test you guys excelled at that part. All right, number 13. This is our vocabulary words. Monomial, binomial, trinomial. Remember those. This means 1, 2, and 3 terms. And then identify the degree. That just literally means to use our vocabulary words that I told you guys during the finals notes. And whatever is the highest degree, that would be the vocabulary words you would use. All right, so the highest degree is 2. So you guys learned that we write that's a quadratic, right? If the highest degree is 2. And then terms. Terms are separated by addition or subtraction. So in this expression, we have 3 different terms. So we call it a quadratic trinomial. All right, with letter B, we literally only have 1 term, right? This is our whole term. We don't have any addition or subtraction in this. So it's just 1 term. And then we haven't learned the vocabulary for this, so let's just say 4th degree monomial, right? Just 1 term I almost misspelled it. Monomial. All right, 1 page done. That's a plus. Almost getting there. Okay, 14, write the polynomial in standard form and identify the leading coefficient. So standard form, we write in order from the greatest exponent to the least. So negative 3x squared minus 2x plus 10. The leading coefficient, that's literally the first number. Remember, coefficient means the number in front of the variable. So our first number is negative 3. All right, so we do the same thing with this. Writing in standard form, we take our 4 first. That's our greatest exponent. Our next greatest exponent is 2, so we write 5x squared. Next, we have plus 7x. And then finally, plus 15. All right, what's the first number here? Remember, it's just 1. All right, question 15. We want to go ahead and add this polynomial together. Remember, adding polynomials, we think of like terms. Like terms, you need the same variable and the same exponent, though. So we can go ahead and add these 2 like terms together. That gives us 7 of those x to the 5ths. Let's see, what else could we add together? 5x squared, there's no other x squares, so we just write that by itself. Let's see, this x and this x could combine. So we have negative 1x plus 8x. That gives us plus 7x. And then lastly, this 10 minus 3 gives us negative 7. So in standard form, I apologize. I keep on yawning throughout this video. But anyways, same thing as last time, right? This is in standard form. And I thought it asked us for the leading coefficient. But yeah, that's all we have to do for this one. They're just asking us to add. That is our final answer. All right, with subtract, very similar, but remember when subtracting, we have to go ahead and distribute this negative to each of these. So let's just go ahead and rewrite this out. 5m squared minus m cubed minus m to the fifth minus 7m cubed, and then this negative turns into a positive, so plus 4. All right, then we go ahead and combine like terms. Same thing as we did with problem number 15. If we have 5m to the fifths minus one of those m to the fifths, we're left with 4m to the fifths. Next, if we have negative 1m to the thirds and we go ahead and subtract 7 more of those m to the thirds, we have negative 8m to the thirds. And then lastly, we just have that 4. So we still have to write that 4, so we just write it. All right, question number 17. We go ahead and distribute this, right? This is our double rainbow. Double rainbow. Okay, so 12x squared plus 8x. All right, yeah, that's our final answer. Question number 18. Remember, this is our double distributive property. So we have to distribute once, and then we go ahead and distribute twice. Double distributive. All right, so if we look at this, we multiplied x times x. That gives us x squared. X times negative 1 gives us negative x. Negative 5 times x gives us negative 5x. Negative 5 times negative 1 gives us plus 5. All right, simplifying our final answer, we just combine like terms. That gives us x squared minus 6x plus 5. Oh, wow, there's a lot of these double distributive ones. But anyways, you guys got a lot of practice with this throughout the year. So that'd be nice for you guys to have this on test. But anyways, 2x times 5x, that gives us 10x. 2x times 4 gives us 8x. Negative 3 times 5x gives us negative 15x. And then negative 3 times 4 gives us negative 12. All right, our final answer. Combine like terms, 10. Oops, I apologize. That's supposed to be 10x squared. 10x squared. This becomes negative 7x minus 12. All right, next one. This one's a little bit more trickier. Maybe it's the same concept, but maybe some of you are confused because, I mean, most of the times you're used to like binomial multiplied by binomial. But anyways, let's just go ahead and multiply this out one at a time. Just take it one at a time as usual. 5x times x cubed, that gives us 5x to the fourth. 5x times negative 5x gives us negative 25x. 5x times 2 gives us 10x. All right, then we go ahead and distribute this negative 3. That gives us negative 3x cubed. Negative 3 to negative 5x gives us positive 15x. And then negative 3 to 2 gives us negative 6. All right, so simplifying like terms. Let's see, what can we simplify? I made the same mistake again. I apologize. Negative 25x squared. That's 10x. Did I do that correctly? Yep. So that's so I did that. Nice. Negative 3x cubed. 15x. Okay, nice. Sorry, just checking my math. Anyways, we go ahead and simplify 5x to the fourth. There's no other like terms. Negative 3x cubed. And then we have this negative 25x squared. All right, but we can combine these two. That gives us plus 25x. And then now we can see that we used all of our terms up, minus 6. All right, question number 21. We want to go ahead and multiply x minus 9 squared, right? So x minus 9. To square something literally means to multiply it out by itself. All right, and then we go ahead and FOIL. X times x gives us x squared. X times negative 9 gives us negative 9x. Negative 9x, or negative 9 times x, gives us another negative 9x. And then negative 9 multiplied by negative 9 gives us a positive 81. All right, simplifying, combining like terms, our final answer, x squared minus 18x plus 81. All right, question number 22. Same thing, it looks a little different because we have an r, but remember these are just variables, so we do the same thing. R times r gives us r squared. R times negative 7 gives us negative 7r. 7 times r gives us positive 7, r. And then 7 times negative 7 gives us negative 49. All right, final answer, we combine like terms, we get r squared. If we combine these like terms, they cancel out, right? They turn to 0, so we don't need to write that. And then we have minus 49. Final answer. All right, that was the halfway point. Okay, factor. Remember, with factoring, we want to always factor out our greatest common factor. So our greatest common factor here is going to be 3y, right? 3y. And then in parentheses, we ask ourselves what we can multiply to get back to this. 3y times 4y squared gets us back to that. 3y times 11y gets us that. And then 3y times negative 2 gets us negative 6y. All right, so if we try to factor this any further using our x method, we can't. So that is the most we can factor it. So we just leave it as is. That's our final answer. All right, unlike x squared minus 7x plus 10, though, we can factor it using our x method. Remember, we think about our x method. We think of two numbers that multiply to 10 and add up to negative 7. Two of those numbers are negative 2 and negative 5. All right, so we can use our shortcut method, our final answer. Right, we write our parentheses, x minus 2, x minus 5. That is our final answer. All right, 25, 2 pages done. Oh, that seems promising. X squared, where are we? X squared minus 14x plus 48. All right, so we go ahead and use our x method once again. Two numbers that multiply to 48 add up to negative 14. That's going to be negative 6 and negative 8. And factoring, we write that out as x minus 6 multiplied by x minus 8. All right, we want to factor x squared plus 7x minus 18. Same thing. Two numbers that multiply to negative 18 add up to 7. Oh, what is this? What's that going to be? Add up to 7? Negative, wait, no, I'm confused. Multiply to negative 18, add up to 7. I haven't done these problems before. 9 and 2 looks promising. Oh yeah, that is 9 and 2. But remember, one of them has to be a negative because we have negative 18. So this number decides which one is negative. Since it needs to be positive, we need to have a positive 9 and a negative 2. All right, so our final answer is going to be x minus, I guess since I wrote the minus first, I'll just do that. X plus 9. Doesn't matter which way you write it. All right, 27, we want to go ahead and factor this. All right, so we use our x method. Remember, we multiply these two numbers together. 3 times negative 2, that gives us negative 6. And they need to add up to 1. All right, so 3 and negative 2 works. But remember, we can't use our shortcut method. right? Because we have an a value equal to 3. It's only, we can only use the shortcut method if we have an a value equal to 1. So remember, we have to go ahead and split that middle term. We split the middle term using these two numbers. We have 3x squared. We can rewrite this x as plus 3x minus 2x, and then minus 2. All right, and then we go ahead and use factoring by grouping. So factor by grouping, we go ahead and do that. We factor this by group and then this by group. So we get 3x multiplied by x plus 1. Then we go ahead and factor out. Remember, if there's that minus in front, this is a little bit trickier to think about, but we factor out a negative 2 instead of just a 2. Negative 2 is the greatest common factor between these two terms, and then that will be x plus 1. All right, now we think of factoring out an x plus 1, right? That's our greatest common factor in between these two. So we factor out an x plus 1, right? We bring it to the front, x plus 1, and then we multiply by 3x minus 2. That's our final answer. All right, let me just draw a line so you guys don't get confused which problems are which. All right, so 28. Same process. We're going to think of two numbers that multiply to, well, 2 times 6 is 12, right? 2 times 6. And then add up to 7. Let's see, 2 and 6? No, 3 and 4. Yeah, 3 and 4 works. All right, so we go ahead and split that middle term using our 3 and 4. We get 2x squared plus 4x plus 3x plus 6. All right, so we go ahead and factor out our greatest common factor from these two and then these two. Greatest common factor is 2x. In parentheses, we write, well, that'd be x plus 2. And then our greatest common factor is 3. And then in parentheses, we have x plus 2. Remember, with greatest factoring by grouping, remember, we know we did it correctly if we have the same thing in parentheses. So we bring that same thing to the front. We get x plus 2. And then what are we left with? Well, we're left with 2x and then plus 3. So 2. That is our final answer for number 28. All right, once more, I'm going to draw this so we don't get confused with which belongs to which problem. All right, factor x squared minus 49. If you guys remember, this one was we have our shortcut method, but this was our other shortcut methods that we thought about. But anyways, it's going to be like, for instance, we have a minus b, a plus b. So the a is whatever we square to get x squared. As you guys know, that's going to be x. And then this whatever we square to get 49, that's going to be 7. So just following this formula, we get x minus 7 and then x plus 7. All right, so now we have number 30. This is our factoring by grouping. We have 4 terms. We need to factor by grouping. Same thing as we did before. Greatest common factor of these two is going to be 4x squared. In parentheses, we have x minus 4. And then same thing as I said before, we're going to factor out a negative 3, right? That's the greatest common factor. And then we have x, so be careful right there. That's going to be a minus negative 3 multiplied by negative 4 gives us a positive 12. Final answer is going to be x minus 4 multiplied by 4x squared minus 3. All right, square root of 27. Using our factor tree method, we can split this up into 27. That'd be 9 and 3. And then 9 we could split up into 3 and 3. So those are our 3 ending of our branches. We can't split them up anymore. So we rewrite the square root of 27 as the square root of 3 squared, right? We always look for pairs, multiplied by 3. And then we could literally take out that square from the radical. So we take this 3 out, and then what's left is only the square root of 3. So that's our final answer. All right, so we can do the same thing with the square root of 18, x to the 8th, y to the 5th. If you go ahead and do this factor tree method with 18, you will get it as the square root of, what would it be actually? 3 squared times 2. And then we want to rewrite x to the 8th and y to the 5th using our squares, because remember during, or you guys learned that we can take out squares from underneath the square root and simplify them. So x to the 8th, we can write it as x squared multiplied by x squared multiplied by x squared multiplied by x squared. Right, remember our exponent rules? That's still x to the 8th power. And then we could rewrite y to the 5th as y squared multiplied by y squared multiplied by y. All right, now we want to take out squares just as we did with problem number 31. So we take that out, we write it at the front. Now we have 4 of these x's we could take out. So 1, 2, 3, 4. But we don't write 4x, right? 2 totally different things. We write x to the 4th power, right? X times x times x times x. That's x to the 4th power. And then we can take out 2 y's as well too, but not 2 y's, y squared. Right, so very close to our final answer. We're left with just the 2 and the y underneath the radical. So our final answer is 3x squared, 3x to the 4th, y squared. And then we have the square root of 2y. All right, 33. We want to simplify the expression. This y got in the way, but on your guys' papers, you guys should see that that's 64 to the 1/3 power. Remember, 1/3 power is the same thing as cubing it. So if we find the cubed root of 64, how do we think of that? Well, we think of a number where if we multiply it by itself 3 separate times, we would get 64. So 4 times 4 times 4 is equal to 64. So the cubed root of 64 is 4. And then I'm sure you guys know the square root of 36. Well, remember, raising it to the 1/2 power, that's the same thing as taking the square root. So the square root of 36 is just 6. And then we get 4 plus 6, which is equal to 10. All right, rationalize the denominator. We want to get rid of the radical from the denominator. As you guys learned in your guys' finals notes or during the lesson, we go ahead and multiply by the square root of 7 divided by the square root of 7. You just multiply by the denominator over the denominator. Doing so, we get 6 square root of 7 divided by, well, we have the square root of 7 squared. So let's write that out. Square root of 7 squared. As you guys know, the square root and the square cancels each other out. So in your denominator, you're just left with a 7. And that's exactly what we wanted to accomplish, right? We wanted to get rid of that radical, and we did so. We only care about the radical in the denominator. We don't care that there's still a square root of 7 in our numerator. So yeah, that's our final answer. All right, 35. Whether this opens up or upwards or downwards. So if you guys remember, if our A is positive, it goes up. If our A is negative, it goes down. So our A value is -1, so it goes downwards. So we just write downwards. Downwards? Well, that's a weird word. With 2 W's, like after that's a weird spelling word. Interesting. Okay. Anyways, 36. Identify the vertex and roots of the parabola. Determine if it is a minimum or a maximum. Yeah, so remember, guys, this word roots, that means solutions. Right, so our vertex, that's going to be, well, you guys know what the vertex is. It's right here. We're finding the coordinate. We move over to the right 4, then we go down 4. So 4, -4. All right, our solutions are going to be wherever our graph crosses the x-axis or our x-intercepts. Right, so 2 and 6. 2 and 6. And then is our graph going to have a maximum or a minimum? It's going to have a minimum, right? This is literally the lowest point it goes. There isn't a maximum because this graph goes on up and up and up. It definitely has a minimum though. So minimum. Or maybe the graph might ask you, what is the minimum? We would say the minimum is -4. Oh, we did that page already? Oh, wow, last page. That's exciting. I'm very excited about that. I am falling asleep right now. I'm trying to stay awake. I'll get through this. Okay. Identify the domain and range of the quadratic below. All right, as you guys know, domain is always -infinity to infinity. Our range literally goes from the lowest point to the highest point. Our lowest point is going to be, well, all the way down here, -infinity, all the way up until this point right here. I know it looks like it doesn't touch it. Well, yeah, it does actually. All the way up until 4. All right, find the axis of symmetry of the quadratic function given the equation y is equal to 3x squared plus 6x plus 4. Remember, axis of symmetry, that's going to be our formula. X is equal to -b divided by 2a. Our b is going to be 6. So -6 divided by 2 times a, which is 2 times 3. All right, so we have -6 divided by 6. That gives us -1. So final answer, remember we need that x. X is equal to -1. All right, find the vertex of the parabola given that equation. Oh, so it's different problems. I thought it was going to be the same one. But anyways, let's just go ahead and do it. We have -2x squared minus 12x minus 16. We can go ahead and use that same thing right here. Remember, our vertex is going to be h comma k. We can find h by h is equal to -b divided by 2a. So we can literally do that same process we did up here. But remember, it's a different equation, so we have to use our different letters. Our b is -12. So if we think of opposite of -12, that numerator is just going to stay positive, or it's going to turn into a positive 12. And then 2 multiplied by a, which is -2. All right, so we get 12 divided by -4. That gives us a -3. All right, so what did we solve for? We solved for the x-coordinate of our vertex. So we need to find out the other coordinate, or the y-coordinate, or in other words, the k of our vertex. So we do that by plugging it back into original equation. So let's go ahead and do that. -2 multiplied by -3 squared minus 12 times -3 minus 16. All right, remember, order of operations, we have to square this first, and then we can multiply. -3 squared gives us 9. 9 times -2 gives us -18. All right, -12 multiplied by -3 gives us positive 36, so plus 36. And then lastly, minus 16. All right, now finally, simplifying, we get -18 plus 36, that's 18. 18 minus 16 gives us 2. So final answer, -3 comma 2. All right, lastly, we have our solve by factoring. So we can go ahead and try to factor this using our x method. I always feel like that's the easiest method to try to do. Let's see if we can think of two numbers that multiply to -8 and add up to 2. Oh, let's see. Before I draw that x, let's just try to think about it. -4. No. +4 and -2. Yeah. Multiply to -8, add up to 2. That'll give us +4 and -2. All right, so since we're still solving, we go ahead and factor this side, but we still have to set it equal to 0. We have x plus 4 multiplied by x minus 2 is equal to 0. All right, so remember, we are actually trying to solve. We're not just factoring, we're trying to solve for x. whatever we can put into this formula to make this equation true. All right, so remember, if we have something multiplied by something is equal to 0, we set both of those equal to 0. X plus 4 is equal to 0, or x minus 2 is equal to 0. All right, so we go ahead and solve these separately. Right, x is equal to negative 4 right here. X is equal to 2, so negative 4, comma 2. That is our final answers. All right, solve using square roots. That's the same thing as solving by getting x by itself. So we have x over here. We can add 44 to both sides. On the left-hand side, that cancels out. We're just left with x squared is equal to 144. And then we go ahead and take the square root of both sides. X is equal to, well, the square root of 144 is 12. But you have to add that plus or minus. We need 2 solutions. You don't need 2 solutions, but if you take the square root of that, you definitely need to add that plus or minus. X is equal to plus or minus 12. All right, 42. Solve using the quadratic formula. Let's just go ahead and rewrite that out. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Oh, geez, I guess I shouldn't have written that out. Let me try to look for another paper. That's okay. We'll try to squeeze it in. Negative b, that's going to be opposite of negative 6. So that's going to be a 6. Right? Turns into a positive 6. Plus or minus the square root of b squared, negative 6 squared, minus 4 times a, which is 3, times c, which is 1. Technically, we don't have to write that, so let's not do it. All divided by 2 times 3. All right, simplifying this a bit more, we get 6. So this isn't the final answer, even though this is on the final answer line. 6 plus or minus the square root. Let's see, square root of negative 6 squared, that gives us 36 minus 12, all divided by 6. Okay, I think I might actually need another piece of paper. 1 second. Okay, we'll just add it down here. Okay, so square root of 6 plus or minus, well, 36 minus 12, that gives us square root of 24 divided by 6. Okay, so we need to simplify the square root of 24 as we did with our problems before on this study guide. So 24, I'm just going to use the quick method. Quick method, we could think of the greatest square root that's a factor of 24. That's going to be 4. So we can split it up into 4 and 6. So if we have the square root of 24, we could rewrite it as the square root of 4 times 6. If we take the square root of 4, that's going to be 2. So we bring the 2 on the outside of the radical. That gives us 2 radical 6. All right, so now let's rewrite the square root of 24 as exactly what we found it to be, 2 radical 6. 6 plus or minus 2 radical 6 divided by 6. And then lastly, simplifying this, the greatest common factor of each of these would be 2. 2 goes into 6 3 times. 2 goes into 2 once. So we don't have to write that 1. Remember, that's technically just 1 multiplied by that. And then 3 goes into 6 3 times. Or 2. Wait. 2 goes into 6, 3 times. So this would be our final answer. All right, hallelujah. We are almost done. 43 and 44. Let's get to it. Quadratic formula. Negative b, that's going to be negative 1 plus or minus the square root of b squared. Our b is I don't know why that took me so long to figure out. Sorry, I'm losing it over here. 1 squared minus 4 times a, which is 3, times c, which is -1, all divided by 2 times 3. All right, so we simplify our radical first. We have -1 plus or minus the square root of, well, that's going to be 1. 1 squared is still 1. Let's see, minus 4 times 3 times -1, that gives us -12, all divided by 6. All right, so simplifying that radical, that's going to be -1 plus or minus, right? This turns to a positive, right? Plus 12. Square root of 13 divided by 6. So that would actually be our final answer because we can't simplify anything else. Can't simplify the 13. 13 is a prime. And yeah, that is our final answer. All right, last one. Wow, this video is almost on 45 minutes. Yeah, solve using the quadratic formula. Negative b. So opposite of -8, that's going to be 8. Plus or minus the square root of b squared, that's -8 squared, minus 4 times a, which is 4, times c, which is 11, all divided by 2 times 4. All right, so simplifying the radical first, we have 8 plus or minus the square root of -8 squared gives us 64. Minus 4 times 4 is 11. 16 times 11 is going to be, what's 160 plus 16, 176. All divided by 8. All right, simplifying the radical. If we go ahead and subtract this, well, we don't even need a calculator. Why don't we need a calculator? Because we know that this is going to be a negative number underneath the square root. And as you guys know, once you have a negative number, oh, thank goodness. I'm so happy that this is one of the last problems because I know that I can stop here. And that's the end of our study guide because I know that it's no solution if we have a negative underneath the radical. No solution. Hallelujah. And we are done. Thank you guys so much for watching. I will see you guys during your guys' finals.